Today we are going to tackle operations on functions. But in this lesson, we will focus on useful applications or items which we can use in preparation for our next topic or lesson, which is rational functions. So we will just solve simple items here. For this topic, we will be tackling 5 operations involving functions. The first 4 are the fundamental operations: addition, subtraction, multiplication, and division. And the 5th one is, I know this is maybe new to you, this is composition of function. So you see here the notation. Composition of function. This is read. We read this notation f circle g of x, or we may write it f of g of x. So for our first item, we have f of x equals 3 plus 2x, while g of x is equal to 4x minus 1, which are both linear functions. So to find f plus g of x, it simply means we will add 3 plus 2x, which is f of x, and 4x minus 1, which is g of x. So here they are. Now our rule is very simple. We will just combine like terms. And in this item, like terms are 2x and 4x. If we'll add 4x's to 2x's, then we will have 6x in all. What about 3 plus negative 1? 3 plus negative 1 is actually equal to positive 2. You may imagine it as you have 3 coins that are positive, while you want to combine one that is negative. And when 2 coins having opposite signs combine, they become 0. So you're left with 2 positive coins. So 3 plus negative 1 is 2. So the value, the f plus g of x is equal to 6x plus 2. Subtraction this time. So this time we want to subtract g from f. We want to subtract g from f. So we want to subtract 4x minus 1 from 3 plus 2x. In subtraction, we have to follow this rule. First, we have to flip. We have to flip our subtrahend, or the second expression. And then, after we flip it, we will proceed to addition. So what do we mean by flipping? It means the terms of our subtrahend will have to be reversed. So 4x will become negative 4x, while negative 1 will become positive 1. After we flip the terms of our subtrahend, we will proceed to addition. Again, we will have to combine like terms. So 2x plus negative 4x, it's like we have 2 blue coins with X inside and 4 red coins with X inside. And when two coins of opposite colors combine, they add up to 0. So we'll have 2 red coins left, and that means the sum of 2x and negative 4x is negative 2x. While 3 plus 1, obviously, that's 4. So that is the answer. This time, we will multiply f and g. And to multiply them, since both are binomial, we will apply the FOIL method. F stands for first, O stands for outer, I stands for inner, and L for last. So for our F, we will multiply 3 and 4x. Look at the red arrow. O, we will multiply 3 and negative 1. Green arrow. I, 2x and 4x. Blue. L, 2x and negative 1. Violet. So the product here of 3 and 4x is 12x. 3 times negative 1 is negative 3. 2x times 4x is positive 8x squared, while 2x times negative 1 is negative 2x. So we have 4 terms so far. And out of these 4, there are 2 terms that are like. So we will combine them. I'm referring to 12x and negative 2x. And if we're going to add 12x and negative 2x, we'll get 10x. So our final answer will be 8x squared plus 10x. I'm sorry, this should be 10x minus 3. So that's it. That is our answer. Now, for division, f over g, we will simply write them as a fraction. So we will write 3 plus 2x in the numerator and 4x minus 1 in the denominator. We don't have to do anything here because we cannot simplify the answer. So that's it. Now, we will perform composition of function. So we are asked here to find f of g of x. This simply means we will have to replace all the x of f. So in our case, we have 1. We have to replace all the x of f of x, or of the function f, with the whole g of x, which is 4x minus 1. So as you can see here, x became 4x minus 1. And then, after we do that, we will simplify the expression. So we'll have 2 times 4x, that is 8x, while 2 times negative 1, that is negative 2. Combining like terms, we will have 8x plus 1. For our second example, we will be solving a quadratic function and a linear function. So For the sum, we will have x squared minus 3x minus 4 plus x plus 1. Since this is addition, we need not write parentheses because there's no complication. We can directly write every term without grouping them. And then we will combine negative 3x and positive x. So there are more negative x's than there are positive x's. So there will be negative x's left. So negative 3x plus positive x is negative 2x. While negative 4 plus 1 equals negative 3. So this is our answer. Like I said, there are more negative x's. So it's like we have 3 red chips with x inside, and we have 1 blue chip. And when 2 chips of opposite colors combine, they add up to 0. So there'll be 2 red chips left, or negative 2x. Subtraction. So this time we will subtract x plus 1 from this trinomial. So what do we do again when we're performing subtraction? We have to flip and add. So we'll flip the subtrahend, the second expression. So if I flip x, this will become negative x. 1 becomes negative 1, and then I'll proceed to addition. Combining like terms, I will just bring down x squared because there's no term that is like it. While negative 3x added to negative x, you get negative 4x. Negative 4 combined to negative 1, that is negative 5. Alright, this time let's multiply the 2. So you can see in the illustration that if we are to distribute the binomial to the trinomial, so this is the binomial, it has 2 terms. This is the trinomial, it has 3 terms. If we will distribute the binomial to the trinomial, there will be 6 distributions in all. So they are numbered accordingly. So as you can see, first we will multiply x by x squared. This is it. Then we will multiply it by negative 3x. Then by negative 4. After which, we'll proceed to 1. We'll multiply it by x squared, and then by negative 3x, and then by negative 4. After that, we will now solve each. X times x squared is equal to, by law of exponent, x cubed. So we have to add the powers. So there is a hidden power here, which is 1. And 1 plus 2 is 3. So this is their product. While in number 2, the product is negative 3x squared. 3. X times negative 4 is negative 4x. 1 times x squared is x squared. 1 times negative 3x is still negative 3x. 1 times negative 4, of course, negative 4. Combining like terms, so I'll just bring down x cubed because it has no term that is like it. Combining negative 3x squared and positive x squared will obtain negative 2x squared. Negative 4x plus negative 3x, that's negative 7x. Then we'll bring down negative 4. So this is the product. While for the quotient, So like we did earlier, we will just place them as a fraction, where f will be our numerator and g will be our denominator. But this time, we have to be observant, because we should notice that our numerator can be factorized, and its factors are x minus 4 and x plus 1. And x plus 1 appears in both numerator and denominator, so we'll have to cancel them. Now, how were I able to determine the factors of this binomial? How did this become like this? The secret is that I will have to look at these two numbers, at negative 3 and negative 4. Negative 3 will be my product, negative 4 will be my product, and negative 3 will be my sum. I have to think of a pair of numbers whose product is negative 4 and sum is negative 3. So there are three possible combinations. 1 and negative 4, their product is negative 4, and their sum is negative 3. There are two other possible combinations. However, I should stop here already, because I have already found what I am looking for. So the pair of numbers that I am looking for are positive 1 and negative 4. Therefore, the correct factors of my quadratic expression are x plus 1 and x minus 4. Alright? Therefore, f over g of x is x minus 4. Composition. Again, in composition, it means we will have to replace all the x's of f with the whole g. So, we'll have this expression. The x's became x plus 1. Then, expanding the square of x plus 1, or by FOIL method, we will obtain x squared plus 2x plus 1. You may verify it on your paper. So what is x plus 1 squared? It means x plus 1 times x plus 1. You may FOIL it. Then, distributing negative 3 to the quantity x plus 1, this will give me negative 3x, while this will give me negative 3. And then, I'll bring down negative 4 or minus 4. Combining like terms, I will obtain x squared plus, so 2x plus negative 3x, that will be negative x, while 1 minus 4, this should be 1 minus 4, that should be negative 3 or minus 3. So, anything clear so far? Now we proceed to operations involving two rational functions. But we will only perform the 4 operations. We will not deal with composition of two rational expressions, because that operation is way too complicated or complex in our level. We will be dealing with such case when we reach rational functions, which will be our lesson next week. But for now, for the sake of illustrating operations involving functions, we will use these two functions whose denominators are both x minus 2. And when two fractions have the same denominator, we say that they are similar. And when two fractions are similar, we can directly perform addition and subtraction by simply adding their numerators and then copying the denominator. So the sum of the two functions is this. Well, their difference will be 3x minus 6 all over x minus 2. Now, we'll notice that 3x minus 6 has a common 3x and 6 have a common factor, that is 3. So factoring that out, this will become x, this 2. So 3 will be factored out. And we'll see x minus 2 appear in both numerator and denominator, so we'll have to cancel them. So the answer is 3. While for multiplication of two rational functions, or simply two fractions, we follow the rule numerator times numerator, denominator times denominator. So that's 3x times 6, and that's x minus 2 times x minus 2. 3x times 6 gives us 18x. X minus 2 times x minus 2 can be written as the square of x minus 2. Right? Next is division. In division of two rational fractions, or functions, we will perform multiplication, but first we have to get the reciprocal of our divisor, the second one, the one on the right hand side. So we'll have to get the reciprocal of this. So this will become, and then we proceed to multiplication. So we'll have 3x times x minus 2, and then we'll have 6 times x minus 2. X minus 2, numerator, denominator, cancel. Then we will notice that 3x over 6 still have 3x and 6, they have a common factor, that is 3. So we'll have to cancel that. We'll be left with x minus, x over 2. Okay? For our last example, we will encounter this when we reach problem solving involving rational functions. So this one is useful. This will be very useful to us in the future. Now, what if we have a rational function and a linear function? How do we perform operations involving them? So we will perform the 4 operations only, and we start with addition. So what is 32 over x plus 2x? So you may notice that the two are not similar because this has a denominator of x, this has an implied denominator of 1. So this has x, this has 1 as denominator. And because they are dissimilar, they are not similar, we are going to manipulate one of them, and that is the second one. We will have to multiply both its numerator and denominator by x, so that doing that we will have a new fraction that has a denominator of x, or we'll have two similar fractions now. And because they are similar now, we can combine them. So we simply add the numerators and then we copy the denominator. So this is their sum. While their difference, we will just replace plus with minus. Same process, same techniques, almost the same answer, except this is minus, this is plus. And then letter C, we will multiply 32 over x times 2x. So we may write the hidden denominator of 2x and then proceed to numerator times numerator, denominator times denominator. That will be 64x over x, or simply 64. Lastly, what is 32 over x divided by 2x? So 2x has a hidden denominator over 1. Then we get the reciprocal of 2x over 1. That is 1 over 2x. Then proceed to multiplication. Numerator times numerator, 32. Denominator times denominator, 2x squared. Simplifying this, we'll have 16 over x squared. Now, the difficult types will be tackled in the next videos. But for now, we leave our lesson be at this level.